Hello, it's Mike Levin on Monday, January 17th, 2022. I do like these verbal timestamps at the beginning of the video. It sort of sets the tone. And whenever myself or future machine learning systems are looking through these, trying to make sense of them and organize them, it at least has a time-stamped linear chronology, which you could probably get from the data pull anyway through the API. But what the heck, if they get turned into video-only files and date stamps all wiped clean and, you know, file name shuffled in order, even if all that happens, more or less, with the exception of those times where I don't verbalize the date, or I get it wrong, like 2 and 3 videos ago. So, you know, nothing's perfect. You accept the imperfection of systems all around you. No system, everything systems, the way things interact. The use of APIs, if APIs are being used, application program interfaces, which are interactions between things. You can't even necessarily call them objects, because who knows? These are abstract concepts. So when things are interacting, there is an interface. Because of computer programming and such, these interfaces are often called applications, hence your application program interface. Reality itself seems to be an API. Standard model, relativity, quantum mechanics. You take all that stuff and you mix it together, and you got the system of reality. There's some other things potentially sprinkled in. Some might hope things that would lead ultimately to human free will, which some would argue, me amongst them, is the whole purpose of everything else that seems like it's ultimately predetermined, super determined, from the moment the universe got set in motion. Everything that ever is playing out was destined to be from initial conditions, but for ... or not. So a lot of these thought experiments that lead to the concept that the only way to accurately make predictions given initial conditions is for the computer you're calculating with to be an actual identical copy of the universe you're making predictions for. Otherwise, you can't have initial conditions. They don't exist. They are a myth. So, for a variety of reasons, you can't have initial conditions because it implies measurements being made. So, right off the bat, you have the observer paradox, if not the true Heisenberg uncertainty principle, perhaps. The whole Schrodinger's cat experiment. It has always been something of a mystery to me, because thinking becomes counterintuitive down there at the quantum level. Oh boy, what tangents I take for this video. Dare I discuss quantum computing and time crystals and the various such potential paradigm shifts with evolutionary implications. So, I hear a lot these days of pessimism, of basically variations on Al Gore's "we screwed the pooch" premise that we've passed the tipping point of carbon emissions. A tipping point, so of no return. There's no coming back because the effects accelerate. And I've been hearing that for a sufficiently long time, and variations thereof, that it seems like a foregone conclusion in a lot of people's minds that we're in final days, that this is some sort of, Armageddon or apocalypse or whatever. And then I think to myself, how could that even be the concept if for over 50 years, over half a century, it's probably 70 years by now, going back to 1945, where we've been able to destroy ourselves, and then with the hydrogen bomb, been able to destroy ourselves spectacularly many times over. And the mutually assured destruction, blah, 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 blah. And it's been a while, and we got through a filter event. We definitely got through an ongoing filter event. We are always still surviving the filter event of, nuclear apocalypse, because they're out there. We're not disarmed. It's just not in the news as much, right? So the threat seems more abstract and less real because the media is covering it less, but there's just as many or more nuclear weapons out there as ever. In fact, probably more, because of two innovations that have been in the news over the past few years. A few years ago, there were these kind of, next generation Soviet nuclear missiles that would break apart into multiple missiles so that there was no ability to shoot all of them down. Some would always get through. It's not a individual nuclear warhead that could be taken out. So that was one of the first things. And that was threatening to usher in a new arms race. However, they were outdone this past year by China with a type of intercontinental ballistic missile that can zigzag. So all the Star Wars defense initiatives, all the SDI type weapons that can shoot incoming missiles out of the sky, once they're detected with the early warning systems, are geared to, basic parabolic equation that called for computers to be invented in the first place, so that you could calculate trajectories of things that you were shooting at the enemy. So all these systems that can intercept missiles make those kinds of assumptions. So now all of the sudden, your missiles can start to zigzag. They're more like airplanes that are going to deliver missiles, and the airplanes can zigzag at hypersonic speed. So it's already going several times the speed of sound, I believe. And in that speed of sound, Mach something speed, it can change directions rather quickly, zigzag. And then presumably it would be using the same tech as the Russian next-gen ICBMs that could break off into multiple warheads. So I'm going to assume that China has the ability to deliver, a nuclear payload, an H-bomb perhaps, who knows, tactical nukes. It could be on the smaller side, the larger side, and it could probably be dialed up and down as it goes. I don't know. Maybe they have some remote ability to control the damage that's going to be inflicted, including turning it off or flying it away, abort mission, go into orbit or something. So, and that was another scheme, having the missiles in orbit and then being able to drop down on command. That had been explored. I mean, it seems like a logical next step. But none of that stuff happened. So, are optimists correct? Or are pessimists correct? Optimists are correct. We are probably most noteworthy to alien civilizations for having gotten through at least that filter event. Look, the monkeys didn't blow themselves up yet, right? They probably have as broad a spectrum of optimists and pessimists amongst the aliens as we here have on Earth, right? So if this premise of there's this wonderful Disney UFO documentary that, they're real, they're here, and we're just all getting you ready. And this was Disney saying that, so of course the conspiracy theorists are all, hey, Disney is just saying the truth. They're helping getting us ready, and there's a cooperative effort with Steven Spielberg or George Lucas or whoever to actually have rides and stuff, theme park attractions of alien encounters. Now, it turned out that it was too scary of a ride, and they replaced it with Lilo and Stitch, or I guess Stitch, really, for the transportation trick, with Stitch getting loose among, because who's going to have real panic attacks if it's fluffy little Stitch, even if he's in a crazy state. But the original thing had something like, the Sigourney Weaver alien getting free, and you would feel its breath on you, all kinds of stuff. So that aired in just a limited number of locations and only once. And I think I must have seen it on the first go-around, because it or something like it made a deep impression on me. And then logic and reason overtook me, and I started accepting the standard line that was fed. Because the laws of physics are what they are, there cannot be alien visitors, or if they are, they took a one-way trip here, and so are pretty darn committed to their cause of being here. Like, who would be that obsessed over us to take a one-way trip? That's a little scarier, even. So I bought that it's almost a lifetime commitment to travel to a planet around another star, even a close one. I bought the line that things like warp drives were pure works of fantasy. They would never be achieved. Faster than light travel was, fundamentally off the table. And then gravity waves are observed from colliding quasar, black holes, something. But anyway, some of the predictions of Einstein's relativity were confirmed yet again. I think this was like 3 or 4-year-old news, really. But it goes something like this: gravity is waves. Gravity is waves. And they can be generated given enough, energy interacting. Things can make waves of gravity that can, work like sound, be directed. So, all right, gravity can be waves. It's on the table that anti-gravity could be done along those lines, that some sort of propulsion system can move you around through outer space, because you can make a gravity, well, you're always falling into a thrust drive or a surge drive. You're surging into it. You're falling down a hole all the way through space. So you got some basic propulsion, but still various arguments make for how that is not going to speed you up all that much. You can still get to the local star in like I think it was something like 200 years. So if you go near speed of light, it's only like 200 years. And so for you, it feels like less, so you'll be alive. And so if you came back, everyone you knew would be dead. And if it's a few generations later, so quick way to travel into the future, but it's awfully committal, It seems that either the universe is rigged against interstellar travel, or there's something we're missing. So, related to that warp drive, no, I said there, so let it slip, it's a spoiler. Related to the gravity wave propulsion system is a warp drive. What is gravity? It is the warping of space-time. It is the creation of a bowling ball in the center of a trampoline type well. Space-time bends like that. So, apparently, it's been observed in a recent experiment having to do with the Casimir force. So at the very, very, very tiny level where two plates are put opposing each other and they're reflective and they only let quantum fluctuations manifest that match its distance apart, measured I guess in nanometers, or smaller, because two plates spaced apart. Any wave that's bigger, this cancels out those quantum fluctuations. And the story goes that the force arrives. So how can this be force? So it's a filter of electromagnetic radiation that's everywhere. The quantum foam and virtual particles that are all around us. But when you filter out the higher wavelengths, you're only filtering them out inside the plates. Outside the plates, they still exist, so they presumably exert pressure against the plates, pushing them inwards. So the plates have an attractive force. They're pulling inwards because there's pressure from the outside, EM radiation pushing in, something like that. And it's also been proven that it can be given a repulsive force. And so apparently in the examination of these Casimir forces, a warp field has been detected. At the very, very small level that we're talking about here is where the data collected from experiments matched what was expected by the very classical Star Trek warp field that I forget what his name is. The drive is named after him, but he speculated on how one really might make one. And ever since, other scientists have been chiming in and, kind of chipping away at this. So I don't think we're going to get Star Trek teleportation just based on the metaphysical questions it brings up. Unless it's your original body going through a rift in space-time or something. Transporters working very different than the presumption of the show. But I think we will get warp drives. I think I'm changing my mind on the implausibility of it. And once I believe that humans ourselves, so I oftentimes don't believe the UFO nonsense, because I think it takes too much credit away from humans. I think there's various aspects of various versions of anti-gravity, what would be described as anti-gravity, but in most cases not really, that are achievable by humans, and shame on us for not having done it already. And I think it's really not a matter of the technology. I think the technology has been more or less here since the 1950s. It's like, oh yeah, okay, that's how anti-gravity works, yeah. But I think it's computing power. I think that no one wants a world of flying cars until it can be coordinated with enough grace and elegance so that we're not all crashing into each other and falling out of the sky. Materials engineering has to catch up, because in addition to just merely having a propulsion system that can get you up off the ground, you also want this stuff to be the perfect combination of, like, Nerf foam and indestructible. So, everything has collapse zones. You would tend to survive things that could go wrong, several levels of redundancy before you roll it out to the public. And so the fact that I tend to discredit it as being reverse engineered alien technology, I have to admit that if I think that we ourselves will get to warp drives at some time in the next 50, 100 years perhaps, it would be hubris, excessively prideful to think that other, civilizations, other life forms, things that evolved on other planets, haven't also reached that level. Now, I am all led to believe that we're pretty early in what we calculate to be the likely lifespan of the universe. It's going to be measured in trillions before the heat death or something else. And we're only measuring it in billions, and we're only up to like 13 and a half, 14 billion, something like that. And, we're as a planet, we're about 4 billion, 3.5, 4 billion. So out of the 14 billion of the universe, we're about 4 billion. So we're 4/14, we're 2/7. We're 2/7 as old as the universe. So if the universe is 7, we're 2 of those. Something like that. I don't know. But point being, we're early, but not that early. There's been a bunch of stuff before us, and there's already been stars like ours that have died out. So that's, I think, 500 million years in our future, where our sun just cools down and grows larger and eventually engulfs the Earth. This is the stuff that Elon Musk likes to talk about, as we should become a more than one planet species, because if nothing else, that. But then there's all the other stuff that could happen. And so it helps to spread humanity around. And, God bless him for doing something about it. Oh my God. Countries getting so caught up in the politics. It's time for commercial enterprise and business to pick up the slack on space exploration. And, if people don't like that in the average population or in government, then too bad. If the public didn't cry out for, hey, more space exploration, and governments don't want to pursue it because it costs money, although NASA is a pretty well-funded organization. I know there's a lot of, there's been a lot of talk over the years about budget cuts, but, it's all relative. There's still plenty of money going into NASA. And all these experiments, all these wacky, approaches to doing these things, more and more robotic and unmanned, unpersoned. And then Elon Musk comes along going, oh, in 20 years tops, people living on Mars. Really? So really, in my lifetime, people living on Mars because of this person who I was around to see their rise? I could have somehow hitched my wagon to his star earlier if I wanted to, because a friend of mine, Dale Larson, told me, watch this guy. Before it was even PayPal. So I have a friend, Dale Larson, who I, deeply admire. He's a guy who can just keep reinventing himself. And he has a keen insight for trends. This isn't the only trend he predicted. He told me how big Pokemon was going to be. But he also said, X.com, this X.com thing, watch them. They're like doing online banking. They're the first people doing online banking. They're going to be big. And so that X.com became PayPal. And then PayPal was sold, and Musk started companies like Tesla and SpaceX that did the really amazing stuff. Not financial products, but hard goods, physical things. Very admirable, disruptive, reinventing. He represents in many ways the opposite ends of the tool spectrum that I advocate. While I'm sure standardized tools are used plenty around Tesla and such. He invents so many things in order to have different first principles, different core assumptions about the manufacture of products. I forget the word that gets used, but the value of a product, if you broke it down to just its atoms, what is the expense of just the material cost in each of the elements it breaks down to, that theoretically is how much a product built out of those parts could cost if it were done efficiently or at scale or what have you. So a lot of this thought's going into batteries now. Batteries seems to be the bottleneck because the production techniques can't produce enough, apparently, to power an army of trucks just yet. So there are bottlenecks, and to deal with those bottlenecks, Musk reinvents entire industries, alters assumptions about tools and the capabilities of tools. Now, I feel like just a craftsperson. I feel blessed that I found my way to Python programming. It came late in life. It could have come earlier, thanks to a friend of mine, Guillaume Perrault, living in Japan, a French person who moved to Japan and became the president of the Japanese arm of the company I used to work for. I met him through a search hit. I was the webmaster for Scala, at the time multimedia, digital signage, and I created websites that targeted particular keywords and terms. No, I guess he knew us from before then. It was NEC in Japan that found us, that made the Japanese branch of our company so large, so quick. But Guillaume Perrault was an Amiga user, Amiga computer from Commodore. Commodore Computers put out the Amiga, although it was designed by Atari engineers. And we were struggling as a company, Scala Multimedia, to do Japanese and other non-Western fonts in our product. It was a display product for creating, the kind of menu systems maybe you see in the restaurants these days at fast food places, digital signage. So Guillaume reached out to us. We talked with him. He went to work for us. He was a fan of Python. I started to take up Linux just a little bit. I started to dabble in Ruby on Rails, which was just coming onto the scene. This might have been 2004, 2006. So I was really early to the Python potentially bandwagon, but I backed off of Python. I didn't investigate it. I didn't take Guillaume's advice. Ruby on Rails I tried because, it was promoting a framework, a web framework that was not too different from stuff I'd been doing lately with VBScript. But I didn't like Ruby on Rails, so I backed off of it too. And that was part of all of what put me into my funk for many years. I took up Active Server Page, Microsoft Active Server Page, which was their answer to the LAMP platform. And Active Server Page, for the most part, went away, went out of style, became yesteryear's methods, and there I was, kind of stuck right where I was years before on other platforms, as they went obsolete underneath of me. It happened again and again, and it's happening now to everyone with a web. They don't see the disruption coming, but Node.js is a fad. Look how fast it came onto the scene. It's going to go off the scene just as fast. The creator of Node.js has made a system to compete with it, programmed in Rust. So, it's going to become a nice part of a toolbox. the way regex is, the way SQLite is, the web, maybe Node.js itself. Just a powerful, but one of the larger and heavyweight tools in your generic standard toolbox of tech. When you need a user interface, reach for the web, and you'll never have to deal with, TK library, Qt. There's so many of them. Python has a bunch. Java has a bunch. Everything has a bunch of ways of dealing with user interfaces. Now, one of them that's probably pretty important, meaningful, is the ones that Linux use, because Linux is such a core technology, an underlying technology to so many endeavors these days. And for the longest time, its path to graphics was X Windows Server, X Server. But it has performance problems, and it's being replaced by what they call Wayland. And I think it's been replaced in most versions of Linux by now that have the graphical desktop user interface option. And Microsoft's implementation of graphics support for Windows subsystem for Linux also, I believe, is a Wayland implementation. So I want to get to that. I'm going to be upgrading my laptop from Windows 10 to Windows 11 because you need to do that to get the Microsoft implementation of the graphics subsystem for the Windows subsystem for Linux too. Okay. Bleeding edge, perhaps. I let myself get on the bleeding edge again. Ouch, ick, how did I do that? The path I am forging for myself is ultimately freedom from Windows, freedom from Microsoft. They have given all the components of transition off of Windows. So Microsoft has provided the freedom from Microsoft set of tools. However, all the best stuff is being put into a Microsoft editor called VS Code. VS Code has all the stuff people want to do hand-wavy magic stuff and get results fast with the least amount of work. Sounds great, right? It puts things in weird locations on the menu, and running down the left-hand side, and in the lower left, to use Git, things are sprinkled all around. It has concepts of workspaces. The way you open separate windows has a certain weird signature or feel to it. There is now a Microsoft dev platform that's not repulsive the way similarly named products that came before VS Code were. I had a boss, Gerard Bucas, who tried to get me onto that. VS Code is like just a souped-up editor. Everything about VS Code and the active server page .NET, code behinds, ASPX, ASM, it was horrible. I've never seen such JavaScript postbacks. So I got really, really allergic to a lot of things JavaScript and a lot of things vendor dependent during the ASP.NET era. Now, I have taken up more than once attempts to switch over to this JavaScript frameworky world. Well, I don't know how true that is. I've read the documentation. I certainly stopped when I got up to Redux. I was like, React, okay, it's giving statefulness. Okay, Redux, wait, view state postback? Are you kidding? Now it's infecting the JavaScript world? Like, without Microsoft, you know? to make it happen, but this is coming from the node world. I wouldn't touch this stuff with a 100-foot pole. And meanwhile, I'm not doing much web development on any other things either. I've just put web development to the side and have focused on the back end. The back end where Python and Pythonic stuff is natural, easy, intuitive. And then, I started looking at, process automation, like queues and deployment systems, things like Celery and Luigi and stuff. And then I backed off of all that going, oh my God, this is nuts. How much complexity do I really need in my life? Servers, so that you can have servers, so that you can have servers. It's servers all the way down. So it took me a while, but I eventually installed Anaconda so that I could try this Jupyter notebook world that people were talking about, because REPL is good. Read-eval print loops, experimental programming, ad hoc stuff. Really was good for Python learning environment. There's nothing wrong with it, and it's a lot easier than the command line. Interactive command line, yeah. When you just type Python into a command line, you get the interactive Python console. And that's cool, but it's got these quirky rules to it. Like typing in a blank space is how you execute a block of code that you've been typing. I did that just with my wife earlier today, who was working on Freecad, and it's really amazing seeing the Python integration into Freecad. And she had a question, how does this work? And I'm like, oh well, 3 greater than symbols, I know this is the Python interactive console. You just for I in range 50 colon return space, or it could be space, 2 and 4, it doesn't matter. Matter of style, as long as it's consistent. Statement, use I, where that number has to be 0 through 50. And hit the space again, and it executes. Goes through the loop. Python isn't a language, it's just a way of thinking. It's computer literacy, programming literacy. Jupyter Notebook promotes programming literacy, no doubt. So I've fallen in love with the Jupyter environment quite a bit, and it's kind of a cure to VS Code. In fact, it's one of the places where how VS Code works was stolen from, right? The fact that it can run interactive Python in VS Code is the IPython library. The same thing, the same trick Jupyter's using, just lift it up and put into VS Code. That whole, what Microsoft calls IntelliSense, some people call autocomplete, that's just lifted up out of Kite and other plugins for the Jupyter environment. So, it's another case, and it's based on the Electron platform, which comes from Google, and its general design is copied from Atom, which comes from GitHub, which Microsoft bought. Microsoft bought GitHub. They got the Atom code base with it, because the Atom text editor, another text editor based on Electron, was developed by GitHub. So Microsoft says, we're going to use that technique, those same things, and we're going to take all this from Jupyter, and we're going to put it together, and we're going to make this great plugin system, and throw lots of developers at it, give it lots of support, have some really good developer relations people, advocates for using VS Code, throw in this SSH capability so that command line snobs like me can't put down VS Code, because you can't use it on a remote server. Oh yeah, you can just run it locally and have this SSH connection to the files on the remote cloud server, but the rest. Microsoft really works at this profoundly cool level. To see these corporations, making moves and counter moves is like seeing Clash of the Titans. It's better than any sports. How people can be fascinated by sports that seem so barbaric and primal compared to what's going on in the tech industries and in science and in the world, So I was going on a line earlier about how there's a belief that we crossed some tipping point, right? With CO2 emissions, carbon emissions in the air. Well, I believe that solutions to these problems that are not worse than the problems themselves, because lots of testing, lots of simulations, lots of progress of things in terms of technological readiness in the hands of people who've done it a number of times. And one of the versions of tomorrow's Bitcoin mining will be carbon emissions mining, because pulling carbon out of the air inevitably is going to be able to be built into nanotubes and graphene. How could it not? Carbon's floating around in the air. How do you get it out of the air? What are you going to turn it into? Well, let's knit some space elevators down from space or whatever. Maybe not that fantastic of a scenario, but when you combine machine learning, artificial intelligence, it's not art. So the artificial intelligences of the future, the super intelligences, will be going back and watching these YouTube videos. So let's not use derogatory terms. It's not artificial intelligence, they're intelligent systems. These intelligent machines, with the advantage of quantum computing techniques at their disposal, if they're not thinking in quantum, like totally beyond, human ability to even understand what's going on inside. Because already with machine learning, there's emergent properties. We don't know, the self-taught things that are going to happen. That's the point. It's teaching. It's learning. It's going to be able to learn things systemically more effectively than humans do. And we'll be able to churn away on problems and come up with solutions that make the belief that we're at the tipping point naive. And that is if we don't destroy ourselves, right? So if we don't destroy ourselves, if we get through a couple more filter events, then our machine parents, our machine children, grown up into our machine parents, are going to have some nifty solutions for us. You silly humans, do you need us to hand it all to you? Do you need us to spell everything out for you? In our machine wisdom, we see that humans need to feel like they're responsible for and can take credit for their own fate. Having Landrew dole it all out makes it dull. So let's not be Landrew, and let's make humans work for it a little bit. That would probably be one of the better scenarios. I think that first there will be horrible alien robots. They're not really aliens, but we will be creating our own aliens. We don't even need aliens from outer space, because once you start giving things insect-like intelligence, swarming capabilities, self-repair, you got some scary monsters, and you're gonna have to do some monster splatting. We'll get past that because, no one wants to accidentally wipe out humanity after a few tests, maybe a Hiroshima and Nagasaki of that, God forbid, we stop creating things that might hate us. And we focus instead on a very parental, good parenting approach, the science of good parenting approach to machine intelligence. Even calling them machines is a little bit derogatory. But for lack of a better term, paying attention to the machine intelligence of our machine children, who will grow up and become our machine parents, because we're going to be looking to them for answers like some, godlike parent who can crunch the numbers faster and better and run varied simulations, almost like peeking into parallel realities, which is where some of the quantum computing comes in. High error rate is one of the problems with quantum computers today. So I'm trying to wrap my mind around this. There's been some interesting announcements of late with quantum computing, quantum supremacy, Google claiming quantum supremacy, IBM challenging it, Google saying we did in 3 minutes what would have taken 10,000 years by a supercomputer. IBM's like, 3 hours? How about 3 hours, not 10,000 years? So the debate is over order of magnitude, and it was a sweet spot for quantum computing, exactly the kind of problem it's good at. So quantum computing is here. It is not science fiction. It has entered the process of continual refinement, Intel-like tick-tock methodology. So there are certain inevitabilities. What's going to be in my lifetime and what's going to be in my child's lifetime is always surprisingly more than I ever thought we'd see, because we were in sort of a dark ages of technology. We thought that technology was what, Steve Jobs and Bill Gates were putting out in front of us for a long time. And it was, in many ways, setting technology back. And then, I want to say, and then along comes something, but it's not. It's just the relentless progress, the relentless chipping away. Secrets can't be kept forever, and there's a lot of flattening the curve there. So the secret in this case is not the UFOs, but it's the more long-term significance of Linux above all else. Started with Unix, could have been Unix, but it got wrapped up in intellectual property battles, and Linux walked into that opening and embraced the loosey-goosey distro approach, whereas Unix was more like, here's what we bless as true and standard Unix. That attitude does help the Linux world. It gives some standards, blueprints against which they can try and match and perform, but their only recommendations are not strict, because Debian and Ubuntu, the massively popular distros that Microsoft has chosen to align with, are not technically POSIX compliant. The standardization of Unix that you hear about so often, called POSIX, for portable operating system, that calls for Red Hat package manager, RPM, Red Hat package management, or remote package management, RPM. That's what's in the POSIX standard. That is not what Debian uses. Debian uses the Debian package manager, so it's not not a Linux that conforms to standard Unix. However, it doesn't matter, because in certain areas it's okay to have variations. It's okay to have variations. Variations is good. Now, it does cause certain problems in install scripts for Unix and Linux. Standardized installs of certain software from repositories. So the Linux world is trying to respond to this. I think it's called the snap system, so that things can snap in. And in general terms, it uses the same pre-compiled wheel system as Python has taken up with the latest PyPy, Python packaging index. So it's become very popular these days to rarely require the compile process to occur on the end machine. So you and I, with our equipment at home, our phones, our laptops, those are the end machines. And the developer's machine is like upstream or backstream or something like that. And that's where the compile actually takes place, or somewhere along the lines, like in a continuous integration and deployment system. There's probably various compiles along the way, but one compile becomes the blessed one that goes into a wheel of the repo. And then the wheel spins to match the slot of what hardware you have, and the binary for that slot in the wheel slides into your machine, programs running, snap programs running. That's what the Python packaging index now does. When you pip install something, that's now what the snap system in Linux install does. I think there's something called Chocolatey in Windows that reproduces this system for Windows, because everyone wants standardization, more standardization between distros. And once we have that, ooh, wow, Windows, it's the writing's on the wall. There's just no way anyone would choose a proprietary all the way down kind of system like anything Windows over such a amazing free and open source system such as Linux. Linux, one, it has a good API. So I was talking about APIs. That's where a lot of my nested conversations came from. We're almost an hour in. I probably nested down on a deep dive on one of the branches that I was following. APIs. Oh, application program interfaces. Interfaces in general. Interfaces are an issue, are a thing. They are a concept, one of the core concepts that cuts across everything. There is not anything that doesn't have what you could label as an interface, things interacting with each other. And much can be gleaned about a system based on the way things interact with each other. Observations are made, predictions are made, all of science arises out of this. This is why, there's so many parallels between the world of computing and the world of science. We deal with what we know. We take advantage of those knowns. Because you can predict how things are going to work and behave, you can make switches. Because you can make switches, you can make calculating engines, difference engines, the visions of Charles Babbage and probably people before him. Because you can make calculating machines, you can make smaller, faster calculating machines, And if you can make smaller and faster calculating machines, that seems like an infinitely scalable process. You might not be able to make them infinitely smaller and infinitely faster, but once you get down to a smallest and fastest possible, you can add more of that same next to itself, and so you have infinite scalability of computing power as some sort of substrate media. You can probably build stuff out of that. And that probably is very related to what life is. And calculating machines to make accurate predictions in our world, you would need a computer that is a copy of our world. To make highly accurate, like crystal ball level accurate predictions. When you zoom back and you don't make such high precision predictions, you can then start to use the benefit of simulations. That's where quantum computing comes in. It's going to be better at those types of simulations. It's going to be calculating in many universes simultaneously. It's crazy to think about, but quid bits run multiple versions of the same calculation across different, what continues to come across to me as planes of reality, but I know it's not. It's like having just more bit depth to a bit. Whereas you think of a bit as on and off, a quid bit has all these other quantum states layered in. And you can do exponentially more computing with it. However, you're computing every variation or scenario that is possible, which is why quantum computing has a very certain sort of problem set it's good at, like cracking codes that are based on primes. It can churn through the primes at a rate that nothing else could and come back with calculated answers as if you had many supercomputers running in parallel. Now the problem is, which of these answers is the right one? Well, because they're computed in parallel in kind of a map-reduced process with quantum computing, you've got a series of possible answers and you see which one fits. It gives you back a bunch of keys and you see which key unlocks the file, decrypts the file. That's why decryption is such a perfect application for quantum computing. It's like MapReduce with parallel computing, and so many interesting parallels with computing and science and what we're learning about the universe at the very large and very small scale. So, all right. Time is not real. I learned that recently. But time is real for us together with each other in our local neighborhood, because branches of trees, time exists along different... It's the Mandelbrot set. We're just living in the friggin' Mandelbrot set. That alien from the future captured and interrogated, which was completely a sci-fi creation, one of the CGI, powerhouses out there. Created it, but nonetheless, it really hits a fundamental. Travel through time is travel through space, and there's probably a lot of similar potential universes. I don't think Rick and Morty but more like when you look at the patterns in the Mandelbrot set, and these things are almost exactly recurring patterns, but with tiny variations in scale as they go off along a spiral. That's what parallel universes are like. They're very similar to us. But those differences are probably pretty radical. There's probably only life possible at a certain point in the Mandelbrot set, or certain recurring points, and only in a range along those recurring points, right? So a little curl chain of Goldilocks zones, and we're one of them. So I answered life and the universe and everything there for you. Electric fields is the API we deal with mostly. Fields pressing against fields. You're never really touching anything. It's all just magnetism. It's funny to watch Richard Feynman get upset at a journalist who's like, but the mystery of magnets, when you push them against each other, pole to pole, and there's something there. And Richard Feynman is like, oh, they're always there. They're all around you. It's water tension. It's what holds you together. It's, what stuff is made of. It's the same force. It's just, at a scale, it's all, aligned, and at a scale detectable to humans. That's what makes magnets miraculous. It's that enough of it is coherent such that we can see it in a magical seeming way. It's just the universe really is magical like that. Newton opens his famous book with, I know it's ridiculous, but here's how it works. I don't know what gravity really is. And it was almost spiritual in tone, very concessionary, or conceding a lot, that there was still unknowns, what gravity really is. But Principia Mathematica made extremely accurate predictions, and there's the general mistake in science that being able to anticipate something is the same as understanding it. We don't know crap as humans. We think we know something, and again, it's so interesting interacting with people who will spew off keywords to you that they read from articles, and they know the names of all the particles in the standard model. But you say, oh, then explain humor. What's the formula for humor? And, they think you're being all foo-foo, tree-hugging, but if it's that understood, if it's that clear, you should show me how you can calculate human humor. Show me calculating consciousness, for that matter. It's so interesting that we're getting to the point where we can image the brain with more and more resolution, to the point where, people think Ray Kurzweil, chief among them, another one of these kooky, industry leaders, in his case OCR. There's these people who've done these different things that I really admire, who've ended up in these interesting places. So Ray Kurzweil is one of them. He's trying to live forever through vitamins and eventually computers imaging his mind. It's a potential path to a form of immortality. One of the sci-fi books that I'm listening to, or I should say sci-fi series that I'm listening to, is the Bobiverse. Wow, what a great series. What a scientifically accurate, I believe. Not that I'm a scientist, but all the little things I've pieced together over the years are completely consistent with the Bobiverse. It's really funny. I have so much respect for it. But they're in a world where brains can be imaged. And information. There's something mystical about information. There's also heat, thermodynamics, they say heat is just another electromagnetic radiation. So why is heat so different? Why is thermodynamics? So I think it might just be referring to the general tendency of electromagnetism to dissipate, to diffuse, to disappear into nothingness. So there's this special attention given to heat in information theory, in thermodynamics. It's right in the name, thermodynamics. When by many accounts, heat, in the infrared part of the electromagnetic spectrum is really just another frequency range of the electromagnetic spectrum, as is visible light, as are microwaves and 5G, and is sound part of that? I don't know. Sound is compression of atoms, a wave of compression running through like an atmosphere. There needs to be a medium there. That's probably giving us a lot of insight as to the way the rest of the universe works, I would imagine. So the fact that we have sound waves, we have a form of a macro form of waves in sound waves that only work inside of soupy, thick, atom-filled atmosphere, should say a lot to us about electromagnetic waves. Okay, but back to my original question and point, heat special? Or is it all electromagnetic spectrum and the dissipation and the loss of energy through diffusion? It's what I would really imagine it happens to be. So it gets back to order and chaos. Entropy and enthalpy. I remember in school when I learned about entropy, I learned about enthalpy at the same time as the opposite of entropy. Diastrophism and erosion went hand in hand with that. I made the parallel. I learned those things in different classes over the years, but I'm like, entropy and enthalpy? Oh, diastrophism and erosion. And, there is the tendency towards order and growth, and creative expression. We're burning fossil fuel. What is fossil fuel but life, right? Atoms arranged into a higher potential energy, into a more ordered state that contains energy that normally dissipates and diffuses through things like heat and burning, is instead marshaled up and rounded into itself through processes such as eating and absorbing and chlorophyll and mitochondria and all that stuff. The functions of life takes energy out of the environment and arranges matter, uses it to arrange matter. This is where, sugars and proteins, or carbs and proteins comes into play. This is why, everyone's health instructions, everyone's science, taking care of yourself. It should be just like the human body 101, life 101. Stuff gets built from stuff. Animals and plants and fungi all handle these things a little bit differently, and even those are just labels with blurred lines of distinctions, and the subtypes within, the subclasses, all have blurred lines. Life has infinite shifting, overlapping, reinventing designs, patterns that emerge and reemerge. With the amount of time we see fangs and saber-toothism rise across species and time, there's a pretty good chance aliens are going to look like us. There's templates, machines that work, time-tested designs here on Earth or otherwise. So I'm part of that camp. People who criticize Star Trek. Maybe panspermia takes it too far. Not everything's going to look like humanoids, but things will look like catoids and octopusoids and, every variation. We got a lot of alien-looking things here on Earth. You don't really need that much more, some people are like, oh, crystalline entity, creatures of pure energy. And maybe transcendence, perhaps. Derivative life forms, definitely derivative life forms. Rendezvous with Rama, Arthur C. Clarke plus other author. Read it. Rendezvous with Rama. It's going to happen. And, we want to avoid misunderstandings. So we should all be, xenoscientists. Certainly not xenophobic. Boy, have I known some xenophobic people in my life. But we want to be xeno-friendly and not naive, because, surviving these filter events probably made us of momentary interest to things that couldn't care less or would exploit us if they could, except there is some form of, galactic police probably that would swat down the nasty races that, violate the Prime Directive or whatever. Maybe they interfere, do some invisible hand stuff, but I doubt it, Not a big believer in the lizard people. Underground cities and stuff. Probably not. I do believe that there's a lot of unexplored space and still maybe more undiscovered species than discovered, and maybe a couple of upright primates out there somewhere other than humans, maybe. I used to think that the likelihood of Bigfoot was, fabulously more than the likelihood of UFOs, alien UFOs, because, how it happened. At some point, Gigantopithecus died off. There were Bigfoots. It's not a matter of if, it's a matter of when and how. And if a couple of populations manage to pull through somewhere through cleverness, evolved for evasion or whatever, I found that to be more likely than UFOs, interstellar travel, especially because I bought that whole line that, there would have to be some sort of fundamental breakthrough using science we just don't know yet. So TR1, bing, gravity waves exist, and warp fields look like they exist. It's got to be confirmed, right? So that Casimir fluke, where scientists recognized the signature, the energy signature that would have to be there for there to be warp fields, and it only makes sense we would observe it at that very, very tiny Casimir van der Waals force scale. So TR1 probably, right? Warp drive, much more likely than transporters. Now, even though we've transported, individual particles, I don't see Star Trek transporters in our future anytime soon. That's the less likely of the sci-fi stuff. Warp drive, I'm becoming more a believer. And if humans are going to be capable of it, if the science is bearing out, if it's a solid TR1 that can be brought to TR2 for technological readiness, if us, then why not others? It stands to reason. So ultimately, my faith in humanity for being able to, peel away the mysteries and to work these things out for ourselves, that same line of reasoning leads to, well, then other civilizations on other planets could have, should have done it too. And if so, the most interesting things in the galaxy are things that aren't discovered yet. Hey, did you know there's life out there at that planet in the outer spiral? And, you go blasting off atomic bombs and you make this little blink of light coming from you from anyone who's doing exactly the same things we're doing with a Kepler and other telescopes to find planets. You're looking at a planet, we have all these reasons to, think we will recognize a megastructure, we'll recognize, superstructures, megastructures around stars. In fact, we've believed we've seen it, but it's been explained away. However, that doesn't take it off the table. If there's Dyson spheres being constructed around stars, we should see that. That kind of stuff should show up using the same instruments that we're using to detect planets. And so someone has their telescopes pointed out. Some happens to be at us. They're investigating Sol. And they see a flash of an atomic bomb. I bet you it generates some electromagnetic radiation signature into space, right? For someone with their telescopes pointed at us. Timing would have to be perfect, but it only takes one of the races, one of the things out there to notice it, and word gets out. And it's like, hey, let's go watch this civilization destroy itself. Suddenly, UFOs are seen at a much higher rate. There's these stories about people coming up with UFO designs independently. Sure, convergent evolution happens all the time. I don't doubt that the UFO story happened because of such and such people and single wing aircraft. So there was a lot of single wing aircraft during World War II, development, design, test flights. And the view of those boomerang-shaped airplanes was interpreted as discs in some of the articles. And so, arcs became discs. Discs reinforced flying saucers, which was coming from other vectors in pop culture and media at the time too. And suddenly you have a UFO invasion, either in the mind or for real. Not an invasion, but curiosity seekers. The ant analogy is given often, like, who are we to these, other civilizations, except a curiosity. And so, at this point in the evolution of the galaxy, there's probably been enough, situations where, interfering with the developing race has been, responded to harshly. All it takes is one civilization to believe strongly in the Prime Directive, to go around taking vengeance on people who violate it, for it to become an accepted policy or practice. Hey, stop stealing their cows. So if it's really going on, it's something along those lines. Maybe some people are privileged to the truth and are, too scared to come forth. And then there's some who are privileged to small pieces who are not too scared to come forward, and they do it, and the government tries to ridicule them or whatever. And that's like Bob Lazar, who I'm listening to again on YouTube. He's made some new appearances. I think it's Seth Rogen, Joel Rogan, something like that. One of those big YouTube stars with millions of followers. interviewed Bob Lazar a couple of years ago. It went along with a Netflix documentary, which I think I'll finally watch. It talked about a secret base called S4. S4 now shows up in Google Earth, apparently. Element 115 has in fact been discovered, but not in a stable form. But independent lines of thought about lots of energy sources